welcome the members here. Welcome the gallery. I'd like to introduce our Sergeant at Arms, Reggie Seals, Joe Cook, and Bill Riley. Thank you so much, fellas, for what you do. We've got a good group of pages with us here this morning. We've got, and I tried very hard to educate myself on the pronunciation, but I know I'm going to mess it up a little bit. Staya Armenimini, back in the back. Welcome. Ava Cooper, thank you. And Staya is here under Representative Robert Reeves. Ava Cooper here is Speaker Dustin Hall. Lovely Harris is here for Jimmy Dixon. Gavin Monroe, Representative Donna McDowell White, and Lucas Snyder, Representative Larry Potts. Welcome. Thank you, Pages, for being here, and we hope you enjoy your experience in the Ag and Environment Committee. I would like to welcome Representative Cook and Representative Lowry to the committee. Representative Ferguson, I understand, who was Representative Mike Clampett's replacement. I was thinking that she was on the committee also, but if she comes in, we'll recognize her at that time. But Representative Lowry and Representative Cook, welcome to the committee, and we hope that you have an enjoyable experience serving on this committee. We have representatives from DEQ, Department of Environmental Quality, here with us this morning that are going to give us a presentation relative to, some people call it biosolids, some people call it sludge, is what their presentation will be about. I would like to say a word or two about the Department of Environmental Quality. The folks over there are absolutely outstanding people who are very conscientious about the regulatory aspect of their work. And we are indebted to the quality of work that they do. They do not have an easy job because political science has a tendency to get involved in some of our agencies, and so they have to fight both fronts. Being a regulatory agency is difficult enough if you do keep just pure science involved in it. And then when aspects of political science get involved in it, Julie, we thank you. We thank you for what you do and the manner in which you do it. And we're looking forward to the presentation this morning. So I have here that I'm to introduce, and at this point, we only use first names. We do not use last names, but if you would like to educate us on that, Julie, we'll be happy to hear that. So turn the time over to you.
Thank you, Representative Dixon. We appreciate this opportunity to talk. And I'm going to talk about biosolids. And I believe most of you got a handout on, or there is a handout, one page or page and a half on biosolids and septage. So you might want to get a hold of that. We tried to answer some basic questions that were established. All right, so what do we mean when we talk about biosolids? Okay. Well, when it comes into the wastewater treatment plant, it's sludge, but it gets treated, and it gets treated for pathogens in particular. And so when it leaves the wastewater treatment plant, it's really considered to be biosolids at that point. Where does it go? It can go to land application, can be sold to the public as a soil amendment, or it can be managed as a waste, incinerated or landfilled. And there you see a pie chart showing in 2018 what we saw happen in the state of North Carolina. But predominantly in the state of North Carolina, it goes to land application. Okay. So a question came up, how do we regulate biosolids? Well, Division of Water Resources, where I'm from, primarily regulates it for land application. We regulate the residuals. We also regulate industrial sludge and water treatment plant sludges and incineration type waste. But other divisions within DEQ regulate sludges or biosolids as well. They regulate septage. It's another term we use for that coming from porta potties, et cetera. And that's done by Division of Waste Management. They also regulate if it's going to a landfill or going to a landfill. And then DEQ regulates the emissions from an incineration process. There are generally two different classes of biosolids. One we call Class A, which has to abide by stricter regulations than the Class B. Okay? The difference being that Class A can be distributed or bagged. So when you go to Lowe's and you get a bag of biosolids, that could be from a wastewater treatment plant, or it could be a mixture of sludges or biosolids, actually. A lot of the land application is Class B, though Class A can be land applied as well. And that is what tends to be land applied. Here's an example of all the land application sites we know of that we have permitted at Division of Water Resources. So we have about 190 what we call non-discharge permits, okay, that cover 2,995 permitted residual land application fields. So one permittee can have 10 fields or 12 fields or even more. But overall, this encompasses 56,470 acres. So a good portion of the state. Greater than 50% of the biosolids generated in North Carolina are land applied. And again, these can be Class A or Class B. So biosolids residuals generated by one or more wastewater treatment plant or a water treatment plant associated with that municipality can be sent, they can be sent to a landfill, or they can be, typically they are land applied and they get a non-discharge permit, or they can be incinerated. If it's Class A, it can can be bagged, it can be used for landscaping, or it can be put on agricultural fields. Okay? And it may do a number of those. It's not usually just one. Class B, it usually goes to permitted fields. Okay? Some of these fields are owned by farmers. So the municipality who creates the biosolids does not always own those fields. They could be owned by farmers. It could be wherever they can apply it in accordance with the rates that are dictated in a permit. So we decided to do a study. And what we wanted to study was PFAS in these biosolids and then in the soil. We also looked at the wastewater treatment plant influent effluent. I will not get into that today. But our purpose was to improve our understanding of the sources of PFAS pollution and its occurrence in wastewater discharges. So, and the biosolids. It's important to note that the regulations that I just showed you earlier, none of them cover PFAS. Okay? So that's just not in our regulations at this time. That's an emerging compound, and we have no regulations that specifically cover PFAS and biosolids. So we wanted to investigate the prevalence of PFAS in wastewater treatment systems at selected sites and examine PFAS and wastewater influent that's going into the wastewater treatment plant, effluent that's being discharged from the wastewater treatment plant, biosolids, and soil from the fields where biosolids have been repeatedly land applied. Okay? We want to generate foundational knowledge of PFAS and wastewater and biosolids for the public information and future minimization efforts to inform our regulatory decisions. So how does PFAS get into biosolids? Well, it enters from industrial users to a wastewater treatment plant. It can enter from residential users, okay? And then it can either go out and be discharged in the discharge wastewaters, or it can be in the sludge that is now turns to biosolids after it is treated. Just for your own information, so you understand, the majority, and I mean a large majority, okay, from 87 to 98% of the PFAS from our study, and again, this is based on the study. I don't know that we can extrapolate it across the state, but our study showed that 87 to 98%, as far as mass, was being discharged, the PFAS is being discharged in the effluent, the wastewater discharged. The remaining 2 to 13% is in those biosolids, okay? So our study included, just for general information, 37 wastewater treatment plants. And we wanted to base it on a variation of characteristics, but size, flow, operating characteristics. So we looked at 3 domestic wastewater facilities. That's all they handled was domestic wastewater, 8 industrial sites, and 26 municipal wastewater treatment plants. Many of these wastewater treatment plants did have industry that likely discharged PFAS, so we knew that going into the study. Then we also looked at 19 land application fields, okay? And they included fields, 13 of them used by municipalities, 3 used by industrial users, and 3 that were mixed. Okay? They had take the sludge from different places and they mix it together. Okay? Most fields in the study had residuals land applications greater than 10 years with repeated applications. And applications had occurred within the previous 2 years, so that's why we went there. And we had to develop protocols to do this testing. There was really no set protocols. EPA generally dictates protocols for our testing. In this case, there aren't any. So we had to develop our own test protocols for testing both the biosolids and the soils. Here's a map of the sites that we tested. Again, it's just showing the circled ones for domestic, industrial, municipal, where we went actually to the physical plant and did their effluent, and then their biosolids. But the yellow squares are the land application fields that we went to and tested the soil. And then we have one bulk distribution facility. That's the square purple one. And so what did we see? And so this is our biosolids results. And you notice that the scale on the left 2 goes up to about 250 or so. And then the scale on the right goes up to about 1750. These all are in parts per billion, nanograms per gram, which equates to about 1,000 parts per trillion. So when you hear us talk about concentration results at Chemours, we're generally talking about parts per trillion. These are in parts per billion, so there's 1,000 parts per trillion with 1 part per billion, okay? What we saw was, and it's broken into 3 groups here, domestic, industrial, and municipal. That solid line in the middle is the average. That top line is the top number is the max, okay? And so for the domestic and the industrial and the municipal, for PFOA, you know, we're definitely seeing it, okay? But they're all not too far apart. For PFOS, and that's the predominant PFAS that we saw in all biosolids, you can see that the domestic is pretty close to the industrial, and the municipal in this case, they're all right in line as far as, they're not too far off, right? The only thing really we can conclude as some of this, and I'll summarize that in a bit, was that the municipal sludge for total PFAS showed the widest range of variation, okay? The dots are the actual sites numbers, okay? And if they had a no detect, it's not on here at all. But you can see there's a few way up there, right, on the municipal. And we have talked to those facilities already, and hopefully they are taking a closer look. But those top numbers can really sway where it all falls. In the soil, we did see significant dilution, okay? Now you can see the scales, 2 scales on the left are still at 250, but the scale on total PFAS on the right is only about 700. Okay, so significant difference. And you see that PFOA, much lower. So once it's mixed into the soil, we're seeing much lower parts per billion numbers. Okay, and look at, and you can see the PFOA is pretty even. The PFOS also not, they're all down around around the 20 range to 33. And again, total PFAS, we are seeing it. And total PFAS, when I say that, that is an accumulation of 57 PFAS that are quantified in the test results. So if half of them were non-detect and half of them were detect, we just added those numbers up for a total PFAS number, and that's how we get it. So it's those that were in the test method that we used and that were quantifiable. Okay. So again, we're seeing the most variation in the municipal wastewater, again, because they get a variation of industrial users. How do we compare to other states? Well, truthfully, we're right in there with other states. The US average for PFOS, again, the predominant PFAS that we saw in the biosolids, is 0.4 to 990 parts per billion. North Carolina was 3 to 256 parts per billion. Okay. I have put some other information here I thought you'd be interested in seeing. Michigan, before they adopted some PFAS standards and some PFAS rules and regulations on their biosolids, was at 3 to 2,150. After they implemented a water quality standard and some other regulations for biosolids, they found they were able to get most of all their biosolids down to less than 100 parts per billion. Okay. You can see Kentucky's range and Georgia's range. Okay. Just to give you an idea what states are doing out there, several states have thresholds for PFOA and PFOS for land application. Okay. They actually have limits in Michigan, Minnesota, New York, and Wisconsin, and recommendations in Maryland. And at least 11 states have monitoring requirements for PFAS and biosolids. We do not, just to be open. We do not at this time. So our general study findings. PFAS compounds were found in the effluent biosolids and soil samples. 100% domestic plants generally had lower average PFAS levels in influent and effluent than municipal and industrial treatment plants. Municipal treatment plants had a wide range of total PFAS concentrations for influent and effluent. And in this study, most of the quantified PFAS load, that's the mass leaving the wastewater treatment plant, are discharged, like I said, to the surface waters. However, 2 to 13% do remain in the biosolids. And PFAS, PFOS, in biosolids, it's a legacy PFAS compound, was detected in 85% of the samples. Okay? And even in the compost samples where they mix wood chips with it, we even found it in there as well. Okay? PFOS is detected in biosolids in 24 of the 26 municipal facilities that we tested on the biosolids. And concentrations in the biosolids were similar to those found in other states. In soil, PFOS was found in the soil samples collected, and it was found in all of them in the land application fields. And levels in the fields receiving municipal biosolids were generally similar to those receiving biosolids from industrial and mixed sources. However, very high PFAS concentrations were found in one field that received municipal biosolids. And we know who that facility is and have since worked with them. So what are we doing at this time? Right now, there is a proposed monitoring and minimization rule that is out to public notice. Okay? And the purpose of that rule is to try to get the sources to do a year of sampling and then to minimize the PFOA, PFOS, and Gen X in their wastewater. We'll see if those rules get accepted. DEQ is collaborating with academic researchers and utilities to identify and understand challenges associated with PFAS and wastewater and biosolids. And drinking water quality in some areas have been impacted by historic land applications. And so we are working collaboratively with a lot of different agencies, utilities, municipalities to try and understand really what happens and how does the PFAS transport through different media. And DEQ is working with sources and communities to understand the extent of groundwater contamination and provide alternative groundwater as it's being done by the Division of Waste Management. And that's all I have. I can take questions if you'd like.
Thank you, Julie. I think from that presentation, to my knowledge, since I've been up here for 16 years, we have not had this quality of understanding, this quality of analysis on this very crucial issue. I personally see a couple of follow-ups for this committee going forward. So I'm excited about this. We'll open it up for questions now. Representative McNeely and Representative Penny, do you have questions or comments? Representative Penny, you're recognized.
Thank you for your presentation. Biosolids are famous for having heavy metals, and I think I heard you say that is something that's really not monitored in the state of North Carolina, but the percentage of heavy metals and who monitors the amount applied and required liming to control the toxicity to plants and animals. Is there any monitoring of that whatsoever?
Yes, that is the one thing we are currently monitoring. We do take a very close look at heavy metals, and that is really what determines, for the most part, application rates, and nutrients as well will determine application rates. But heavy metals are looked at, yes, sir.
Follow-up?
Follow-up. The second part, is PFAS or PFOS considered a heavy metal, or does it have similar chemical properties to cadmium, chromium, mercury, and zinc, the heavy metals? Is that, how's it classified?
It's not a PFAS. PFAS are notorious for their fluorine, and carbon structures that are very unbreakable, which is why they refer to them as forever chemicals. But metals are their own set of group of parameters that and compounds that we measure.
Okay, thank you. That's it. Thank you.
Representative McNeely?
I don't have any questions.
Thank you. What we'll do now, recognize members of the committee, and what I'm going to do is when I recognize you, I'll recognize you for 2 questions or a comment. I'll come back to you, but then I'm going to go to somebody else. And as long as there's somebody else, a new one that hasn't question or comment, then I'll work back around you. Representative Harrison.
Thank you, Mr. Chair. I hope this doesn't count as one of my 2 points. I just want to, I just want to thank you for holding this hearing, because I think this is a really important issue. We've been talking about it for a lot of years, but never at this level of detail. So I'm grateful for your leadership on this. So now I'd like to start my 2. I appreciate your presentation. I appreciate y'all's work on this. I've been very concerned about the level of PFAS chemicals, the family of PFAS chemicals, getting into the food we eat because of the application of the sludge. And so I don't even know where to start because my list is pretty long, but I will just start with the point of the level of scrutiny on so you're looking at just PFOA, PFOS, and Gen X because there are 15,000 in the family. And when you are, say this proposed rules on monitoring and your rules on in your study, efforts, it only includes those 3 chemicals and not any of the others, PFMOAA and all those that, I mean, I know there are a lot of unknowns.
So right now, the test. So
You recognize.
So yes, the study itself, the test method that we use is commonly used by a lot of people. It covers 57 different type of PFAS. Okay? And that's what we used in our study, and that's what we came up with conclusions. However, the rule that is proposed to only regulate PFOA, PFOS, and Gen X.
Number 2.
Thank you, Mr. Chair. So I guess I'm going to go to the rules that are currently proposed, and I assume that's what's coming out of the EMC because originally there were like 8 chemicals and now there are 3, and you referenced that that's going through the rulemaking process right now, but it's just simply to monitor, but not to limit the input of those chemicals. I realize it's been going through a multi-year process, but if I have that right.
Julie, you're recognized to try to answer that question.
Okay, yes. You are correct. There are no limits in these rules. The purpose is to monitor and then to minimize as best they can using best management practices. And that is what is in the rule.
Representative Butler.
Yes, sir. I would like to thank you also for bringing this forward to the committee. I think it's really helpful for us to begin to understand, what we're dealing with. And I wanted to understand, I think I heard you say that your slides there were in parts per trillion. Is that right?
Julie?
So the slides that I showed data on were parts per billion.
Okay, so that would be more
This is
diluted.
number 2.
I'm sorry, sir. That would be more diluted than parts per trillion. Forgive the mathematics of this is over my head.
Julie?
So there are 1,000 parts per trillion and 1 parts per billion. So it means it's higher.
Representative Majid.
Thank you, Mr. Chairman. I'm curious to know about these pathogens. Could you share with me how they are removed, and is there a limit, percentage-wise, after they're removed? Say it can't exceed this amount. Could you talk about that?
Julie?
So I'm not going to say I'm real familiar how the packaging works. I just know that if they're Class A, they can go for distribution, for bulk distribution, and they go to a set facility and they would package it and release it to, and it could be like a Home Depot or Lowe's, whatever, or for landscaping. That's unfortunately all I know about it.
And follow-up.
Follow-up?
So you said that, so there are pathogens in there, but they come under the standards. They are below the standards that the state utilizes in as far as the law is concerned. Is that correct?
Julie?
Yes, sir, that is correct. It's regulated for pathogens, and Class A is regulated much more stringent than Class B.
Representative Wofford.
Thank you, Mr. Chairman. You probably said, but what do you do with those that aren't land applied or for agriculture or for the sludge? As you said, something like 75% was land applied, but where does the rest of it go?
Julie?
At the very first. Yeah. I got one more.
So the majority is land applied. The other is sent for 21% for incineration. The others is bulk distribution, like we just talked about, and 9% for landfill burial. And then we have other, which are something called surface disposal units, which are very specific for specific kinds of waste.
That's
Follow-up?
Yeah, you had another question. On that one graph about the PFAS, there was 2 little dots at the very top of both of those graphs that were particular sites, for each one of them, of the 2 that controlled how high the graph actually went. They were that much different from everybody else that was all at the bottom. You see what I'm talking about? It's on the, and I can't say that exact slide, but I assume that those people, there's something really serious about those guys. That. See the 2 little dots at the very top, control, and then everybody else is down halfway down the thing, and then most of them are down at the bottom.
Julie?
Yes, sir, you're exactly correct. The dots represent a facility and what we measured as an average of samples at their facility. For instance, that middle industrial are 2 military bases at the top. I'm going to tell you that right now. Okay.
That's big.
Representative Ager.
Thank you, Mr. Chair, and thank you for having this discussion. I'm just going to have one question, and the question is, you talked about this rule, is monitoring and then using best management practices to reduce. what are those best management practices that we're finding are useful in reducing these chemicals?
Julie?
Okay. So it varies on the type of industry. And we watched Michigan do a little bit of this work, and it was a learning process. So if you're a chrome suppression facility, there would be specific practices for that. So it depends on the facility type. But overall, the best management practices in our eyes would include sampling your processes, figuring out where and what materials have PFAS at your plant, and then taking action to reduce that.
Follow up? Representative Harrison?
I appreciate that, Mr. Chair. I've been trying to contemplate how to consolidate this. So in understanding the regulatory landscape on this particular issue, you pointed to the federal regs, and I assume that DEQ staff is the one that enforces the regs. And don't answer anything because I don't want this to count as a question because it's a long question. I'm sorry, please don't. Okay. So anyway, because we've been talking about this issue for a long time, and we know this PFAS danger, these carcinogenic chemicals, harmful chemicals are ending up in the sludge. It's going on farmland, getting uptaken in the crop, and we are consuming it, and they're finding that. So I'm just trying to figure out, what is your enforcement authority? What can you do to keep this from happening beyond just monitoring? Because if you're telling the industries that are discharging these chemicals to do best management practices, that doesn't give me a lot of it leaves a lot of concern. It doesn't give me much comfort. Can you talk a little bit more about what your regulatory authority is and what maybe we need to do?
Representative Harrison, I'm going to comment and then Julie can answer. I think that's the very purpose of what we're beginning these dialogues about is, from what I've heard so far, we've done very little. And they have very little direction at this particular point. If I'm totally wrong about that, Julie, you can address Representative Harrison's question.
Thank you.
No, you're correct. It's been a struggle trying to address emerging compounds. There are no regulations for PFAS in biosolids, state or federal. And there are no surface water quality standards for PFAS either. The only thing we have are some drinking water MCLs that will go into effect in 2029. At this point, it may be extended. So there's very limited standards out there. The Division of Water Resources, the DEQ did propose water quality standards for PFAS, I think it was the last July, and those were not approved by the EMC. They wanted to go with the minimization plan. And so that is usually the framework from which we work, water quality standards.
Follow up?
Yes, sir, please. So is there a way that, for instance, I was looking at that, and maybe if I'm interpreting it right, but those numbers, if you're in billions and you translate it to parts per trillions, it's going to be a pretty high number. But is there a way the industrial discharges, and also I would like to include 1,4-dioxin because I understand that's an issue too, not just the PFAS chemicals, similarly harmful. Is there a way that the industrial dischargers or the municipal wastewater treatment plants have to go through any more, with your current authority, to screen out or engage in some better process of removing those chemicals before they actually get into the wastewater treatment plant? Because you just can't force every wastewater treatment plant in the state to spend hundreds of millions of dollars to upgrade. It ought to start at the point source. So what do y'all have any authority on that end?
Julie?
So typically how it works is the state adopts a water quality standard. We put that limit on the municipal wastewater treatment plant's effluent discharge, and with their pretreatment program, they work back and they see where it's coming from, and then they regulate all the industrial sources going to them. Okay, and that is typically how it works, but we don't have those standards. The minimization plan is trying to do that. They're trying to say any industrial user who has a detectable level of PFOS, PFOA, or Gen X should look at their system and try and seek best management practices to try and reduce them. So the difference is with the water quality standard, we have something very definitive, something enforceable, and they know what level they're trying to achieve, okay? With the minimization, it's not quite as clear.
Representative Butler, do you have a follow-up?
Yes, sir. Thank you, Mr. Chairman. You know, I come from the genesis of this thing down in New Hanover County, and, you know, my folks have been clamoring for guidance and clamoring for standards and so forth. And as my colleague said, getting to the source of these things would just be the most logical and effective manner of doing that. If we just go with a minimization standard, and forgive me, that seems just like a trust mechanism. And my community is kind of fearful of that because we've seen that has not been effective in the past. Am I correct? If you're talking about minimization only, isn't that just a self-policing situation?
Julie?
I believe that's correct.
Yeah. Thank you, Mr. Chairman.
One more follow-up? Representative Lofton.
Thank you, Mr. Chairman. This is a follow-up question, I guess, along the lines of the question you heard earlier. I guess the initial question is, did I hear correctly? I guess that Michigan is probably the farthest along in terms of developing an effective regulatory structure to deal with, I guess, both the, and I'm going to mangle these terms, the effluent and the influent in terms of what's coming in and what's going out.
Julie?
So Michigan has a lot of PFAS, and they have done a lot of work, I'll put it that way. There are some other states that have done but Michigan has kind of shown us a little bit that if you adopt water quality standards and you adopt some rules or strategy on these chemicals, PFAS, that you can indeed affect change and get reductions.
Okay.
Follow-up?
Yes, and then I think I heard you say basically, essentially, there are two parts to it. So one is the water treatment plants need to adopt some strategy for minimizing the amount of PFAS in their effluent and in the biosolids. And that cost obviously is being borne by the municipalities who are operating these water treatment plants. Do we have a sense, I guess, for the scale of that cost and how much assistance would be required to help them do that? And then I think I also heard you say there is existing authority, or maybe there could be existing authority for them to then pass those costs back upstream towards the actual sources of that, or is that something we would need to look at in enabling?
Julie?
Okay, so we are finding that water treatment plants are bearing the cost of PFAS removal because they have the MCLs they're going to have to meet. Question, is it much more cost effective that it's done at the source? Absolutely. It can be a simple process waste stream that all you have to do is remove the PFAS or change the materials that you're using, and it wouldn't discharge PFAS at all. So it's much more cost effective to go to the source. However, it is true, our water treatment plants are likely to bear the cost of PFAS removal. Okay. So it's not it's removing it at the water treatment plant for the water that's to be distributed to the public, just to be clear on that.
Representative Penny, I'll say at this time, members of the committee, we can go to 12:15 if the committee members still have questions. We'll extend this to 12:15 without objection. Thank you. We'll extend it to 12:15 if needed. Representative Penny.
Changing gear, but similar subject. Is there current monitoring for 1,4-dioxane in municipal sludge?
Julie?
I don't believe we did any monitoring for 1,4-dioxane in municipal sludge. I can't recall, to be honest. I'll have to check.
Follow-up?
Put it on your radar screen.
Representative McNeely.
Thank you, Mr. Chairman. I'd like to ask Julie maybe like a little bit of series of questions. Has DEQ done any forage sampling on the actual crop or pasture land that the effluent was applied to after going through the wastewater treatment and found PFAS in that forage sample?
Julie?
So yes, sir, that's the soil sample we did. This is the soil where the crop is.
Good.
Okay, this is the soil on that field.
Follow up.
Follow up?
No, ma'am, not the soil, but the actual plant that would be consumed by an animal.
Julie?
No, sir, we did not do that testing.
Okay, so follow up.
Follow up?
So in your mind, you're not sure if there's any PFAS that actually transferred to a plant then and then was consumed by an animal?
So I cannot say that at all.
Okay.
And from what I've read, it probably some has transferred to the plant, but that is not Division of Water Resources expertise and wouldn't be something that we study. The collaboratory I know has done some studies on that, and so there is definitely information out there on that.
I will make a comment about that relative to, some of you might be familiar, cattle farm in Texas. I think about 9,000 head of cattle that had to be shut down. The municipal sludge application on that farm was obviously in the forage that the cows were consuming, and they did eventually find the PFAS in the milk that the cows were producing. So that's one instance, Representative Neely, that I remember where, you know, there was documented situation to where the actual forage consumed by cattle ended up with some trace elements of it in the actual milk. Do you have another follow-up?
Yes, real quick, Mr. Chairman.
Yeah.
Ms. Julie, can we actually detect down to parts per trillion, or is that more of a mathematical equation?
Julie?
No, sir, it's not a mathematical equation. We can actually detect down to parts per trillion.
Okay.
Representative Ager, you have a follow-up?
Thank you, Mr. Chair. And yeah, just a quick follow-up as I'm thinking through this, you know, process of moving it from industrial users to wastewater treatment plants. But, you know, can wastewater treatment plants just refuse to accept industrial PFAS waste?
Julie?
So they have their own local ordinance, and they can refuse to not take things. Yes, sir. They can, it's primarily based on usually the federal regulations, something that would cause, inhibit, or damage the processes at the plant, or wouldn't protect the effluent, the water quality standards in the receiving stream. So generally, that's what they base it on. But they have the authority to do that, yes.
Follow-up?
Quick follow-up. Thank you, Mr. Chair. And so that's what, you know, having that wastewater standard at the end would allow them to say, you know, we can't accept this waste because it's putting us out of standards on the back end of the plant.
Julie?
Yes, sir.
Go ahead, Blair.
Thank you, Mr. Chairman. Julie, is there a safe level of PFAS, say in parts per billion in drinking water, or is this a no tolerance kind of thing? Any at all is bad?
Julie?
So I'll just have to say that the federal government came up with MCLs, maximum contaminant levels, that they recommended would be safe for the public to drink. So they have, for at least for 8 parameters or 6 parameters, I'm not sure. PFOA, PFOS, Gen X, a list of them. And so we don't have them for all of them, but we have them for a group of them. And that's what has been defined scientifically so far.
Follow-up?
Yeah, do we know that in parts per billion or yet?
Julie?
Those regulations are in parts per trillion.
Representative Butler?
Yes, and so you talked about this pre-treatment authority that wastewater treatment facilities have, and I understood you to say that it emanates from ordinance. What's the pre-treatment authority that these facilities actually already have?
Julie?
Okay. First of all, I'm going to correct my answer and say there's 4 parameters regulated under the MCLs, so I get that clear. And then, as far as for the pretreatment authority, so it was established quite a while ago. The federal government recognized that all these industries are discharging to municipalities, and you needed to get control over it. They needed to have some sort of authority to regulate what they were receiving at the plant. And so, they came up with a program called pretreatment, and they, have anybody that has a significant industrial user, and there's a set definition for that. It could be the volume of flow, it could be the type of waste that are in that discharge to that wastewater treatment plant. But they gave them authority that you adopt an ordinance that gives you all that authority to monitor them, to give them an industrial user permit, to regulate what they discharge and what they're allowed, and to base that on what they can receive at the influent of their plant, beginning of their plant, that will not harm it, processes, and will allow it to meet effluent standards. And so all that authority was written into this ordinance. However, if they feel that anything, there are some ordinances that have been expanded, if it's a threat or a nuisance or other things, that they have some authority then to just regulate what they need to regulate to protect the plant.
Follow up?
Yes, sir. I guess, is there any enabling legislation that has to come from the county or the municipality, or is that just embedded into federal law?
Julie?
So I'm not sure I understand the question. Enabling.
So.
You want to
follow up,
repeat
sir?
the question?
Yes, sir. So this pretreatment authority emanates from the federal government.
Julie?
Right.
So it was an idea that they have to adopt something and it has to meet certain minimum requirements. And they specified that. And so they have to adopt that at a minimum, however, it can be expanded upon if they please.
Yeah, and Mr. Chairman, just one more quick thought.
Last follow-up.
Yes, sir. I guess what is troubling or confusing me a little bit was when you say ordinance, that makes me think of municipalities and counties. You know, Cape Fear Public Utility Authority, as an example, doesn't have an ability to create, I don't think, an ordinance per se. So when you say that, I'm confused about where the authority is emanating from, or who has to take some action to create that authority.
Julie?
So my understanding is Cape Fear Public Utility does have the authority, and they did adopt such rules. However, it fits within their governmental body.
Okay, thank you very much.
Representative Harrison?
Thank you. Same theme. I appreciate that. And what I'm wondering, and maybe I misunderstood you, is that maybe a local government has the discretion about whether they'll adopt such an ordinance about that. So please don't answer yet. So because what I'm thinking about is if there is, and also if there is no drinking water standard, if there's no health standard, or like the 4 that have been proposed by the EPA, but are not yet standards in law, can these local governments add anything like 1,4-dioxin? Because I don't know if there's a drinking water standard for that. But I know that, like Representative Penny, it's dangerous, and we've got a big problem with that up in Guilford County and Alamance County. So can a local government, 1, refuse to adopt standards? 2, can they add a standard for like 1,4-dioxin if there isn't one in federal or state law? I guess that's my first question. It's hard to manage all the questions I have into 2, so thank you.
We'll have another opportunity.
No, thank you.
Julie?
First of all, as far as discretion, if they're required to do a pretreatment program under certain circumstances, if they have a significant industrial user, they have to adopt certain regulate ordinance requirements. As far as, it gets sketchy as far as can they just, I have found that local governments are very weary to go just give, they can't, to make up a number without some scientific or criteria or standard that is out there. Okay. But they do, the regulation does allow them, again, if, take chloride, salt, okay? Even salt is dangerous at a certain level, okay? If you're gonna put bags of salt down the drain, it's going to kill a wastewater treatment plant. So they have the authority, if they're seeing something, kill their processes to stop it, okay? But then to just, unless they unless they see that right off, then they might not be just wanting to adopt a number without scientific or a criteria or something out there. So I do find that local governments struggle with adopting their own set of numbers. But they do have the authority to stop something if they see it causing problems at the wastewater treatment plant.
Thank you, Julie. Members of the committee, I'm going to make a couple of general statements. And then, as I said, if we need to, we'll come back around until 12:15 with some additional opportunities for questions. I would just like to make, as chair, I would like to make a couple of overall statements to put some perspectives on this. Members of the committee, we are consumers. And the more affluent we get, the more things we consume. The more things we consume, the more waste we produce. So it's like I told one committee when we were talking about the coal ash. Some of the folks that were so critical, I just point to them and said, "You're the problem. You're the one that created it. You created it when you flipped the switch on." Point number one, we're consumers and we consume a lot of stuff and we produce a lot of waste. 2,995 fields where this stuff is applied. 19 studies, that's 6 thousandths of the fields that were out there. 56,470 acres. And Julie, I'd really like for you to verify that. I think it's more than that, but I could be wrong. It's a lot of acres. 87 to 98% is being discharged as effluent. That means that we're putting it in the waterways. The other, let's say 10 to 2% of PFAS that they found has been land applied. I think that's important. So, Representative Harrison's questions and other questions are, I think, appropriate when she's talked about standards. I think the most important thing, Representative Harrison, that we have to do on a federal level, as here, is come to the right standard. You remember that hexavalent chlorine that scared the pudding out of everybody, right? That was called political science. We don't need that. We need science if we're going to tackle this problem, which is a huge problem because we are consumers. So developing that standard, Julie, and you other folks from here, I hope that you all have input when these standards are developed to educate us and let us know if these standards are really scientifically based and if they are standards that we need to try to achieve in order to solve some of these problems. The next time that we come in, we didn't discuss one thing. Across the state now, we've got these large concerns coming in with digesters. A digester is a place that takes all of this kind of stuff that's too nasty to go anywhere else. We've got one in Duplin County in Warsaw. And that digester, when folks do turn down certain types of waste, we've got this new entity coming along that's a digester. And I might be wrong, but I describe it as the nastiest of the nasty. And they supposedly have systems or technologies that come in and make it not so nasty before it's disposed of. So I would like a little more information myself on the digester situation. Thank you so much, folks, for letting me editorialize for a few minutes, but I don't think I'm far off base on those things. So we'll allow for a couple of more questions. Representative Harrison, or comment.
Thank you. This was just my second question, because I'd asked about the 1-4 docks, and do we have a standard for that? And I understand that you might be able to regulate, even if we lack a drinking water standard, there are other standards that would allow it to be regulated before it gets into the wastewater treatment plant and end up in the sludge.
Julie?
Or can I not ask that because this issue is in litigation? Is that what you're going to say?
No, ma'am, I'm not going to say that,
Oh.
but I will point you to a resource that is available to the General Assembly. About 2 years ago, DEQ was tasked through a legislation to do a 1,4-dioxane human health risk assessment study. And that report, we can make that available. The staff across between DEQ and DHHS developed that report, and it was a compendium of all the latest human health data and scientific information. And through that, we made some conclusions. That report was then also reviewed by the DEQ Science Advisory Board and supported. And so we can make that report available, and it does have the data.
Thank you very much. At this time, other representatives of DEQ, would you like to make any closing statements, Michael, or any of you?
So on behalf of DEQ, we really, really appreciate this opportunity to have this dialogue and information exchange. We do want to emphasize that DEQ has been operating under our PFAS action strategy. What that allows us to do is prioritize 3 things. One is about identifying communities that may have their drinking water or their land affected from historical PFAS, and we have been working on that. And through that, we have been giving out filtration through the Bernard Allen Fund and providing other technical assistance. The second is looking at sources of contamination, and you all talked a lot about that today, which is how do we address that through minimization, through regulation, and through voluntary actions and awareness. And the third is really holding polluters accountable. We know we have some legacy contamination, and we know who those responsible parties are, and just to be able to hold those folks responsible so that the ratepayers and the utilities are not bearing the cost of it.
Thank you so much. Is there any member of the committee who has not asked a question that desires to do so now? Thank you so much. We're adjourned.